All right, Unit 2, factoring. The first kind of factoring we are going to discuss today, or have a video on today, is factoring using the GCF and DOTS. So first, GCF. GCF, remember, stands for the greatest common factor. And that's a term that divides evenly into all other terms. Okay, so to find that, you find a number that divides in each term and a variable or factors that are in the GCF if they are in each term. So they're in the GCF if they're in each term. And then the exponent on the variable or the factors is the lowest exponent on it. So let's just go through it in a basic example. So if I want to factor this, all we know is GCF, so that's what we're going to use. So you look here. So I usually do it in pieces, but it is all one problem. So I look at the numbers first. It's truly up to you what you wish to do. I'm going to use purple. So 8, 2, and 4. So is there a number that divides evenly, the biggest number that divides evenly into 8, 2, and 4? Well, that's 2. 2 goes into each one of those numbers. So 2 is in the GCF. Okay? Then I look at each of the variables. So the next variable is, then we look at x, or all the rest of the factors is a better way to say it. So since x is in each term, remember there are only 1, 2, 3 terms here. So x is in each one of them. So x is in the GCF. Now, what's the exponent that I pick? Well, look at the exponent on each of the x's. 3, 2, 2. Pick the smallest one, 2. That's it. That's what you do. Okay? Then we look, okay, here's a y, and a y. Y is in each one of them. I'll pick black, I guess. And then look at what's the exponent I'm going to pick. Well, the exponent here is 3. This is 2. Remember, there's nothing there, but it is a 1. So the exponent on the y is the 1. You can either write it or leave it just the way it is. Okay, now there's a z. So there's a z in this, but not here. So it's not in the GCF. That is the greatest common factor. Now, but we're actually factoring. So, which is basically dividing. We're factoring out and making it the opposite of all the multiplication problems we did last week. So what you do is you take this 2x squared y and you divide it into each one of the terms. So now you kind of know why we did all those exponent rules. We're not specifically saying use the exponent rules, but you have to. Okay? Divide the numbers. So in the first term here, divide the numbers. 8 divided by 2 is 4. Subtract the exponents. 3 minus 2 is 1, so we can leave it like that. Remember, that's y to the first. 3 minus 1 on the y's, so that's y squared. Z doesn't have anything to subtract, so it stays there. Next, we have 2x squared y squared z divided by this. So 2 divided by 2 is 1. You can either write the 1 or leave it off. It doesn't matter. X squared and x squared, that's exactly the same, so those are gone. So then this is y squared divided by y to the first. So that's 2 minus 1, or just y. And z doesn't have a pal to subtract, so it stays z. I just put my line through my z. I just do. Okay? Keep the signs unless the GCF is negative, which 90% of the time it is not. Make sure the signs stay the same. This is negative, so this is negative, this is positive, this is positive. Then divide the numbers, subtract. Remember, x's go away, y's go away. They're exactly the same. We're just left with 2. I can't erase that. So we're just left with 2. This is factored. It's messy, but that's it. That's all it is. If you keep yourself neat and you follow step by step, it's quite simple. So if we look at this one, this has 2 terms, and it's important you can actually see the 2 terms. Okay, if you want to find a number that goes into the 2 and the 6, so that's 2. I'm just going to move this down a little. so I can divide later. If x is in both of these, so we take the lowest exponent. There's a 1 and a 2. This is a 2, that's a 1. So I'm going to pick x to the first. And this is a factor. X minus 1 is a factor also. So that is part of the GCF. So then I just simply divide by 2x times x minus 1. If you don't like the x minus 1, remember you can make it an a. And just have them a's, and it may be clearer for you. So I'm going to x minus 1 and x minus 1 are the same there. 2 and 2 is the same. X squared divided by x is just plain old x to the first. And then here on this one, 6 divided by 2 is 3. Again, remember the sign here is negative, is 3. The x's cancel out, and the x minus 1's cancel out. So this is it factored, and you factored out a GCF, and this was your GCF. It's crazy, but that's just the way it is. It's awesome. Okay, dots. Dots is the difference of two perfect squares. Okay, so you have a perfect square minus a perfect square. So when you subtract perfect squares. So just to discuss what a perfect square is, it's anything you can multiply by itself. Okay, so if you multiply 1 times 1, you get 1. If you multiply 2 times 2, you get 4. Notice I'm multiplying 2 times itself. So it has to be multiplied by 2 of the exact same thing. 3 times 3, 4 times 4, etc. Okay, so these are some perfect squares here for numbers. Letters or variables, okay, x squared is x times x. X to the fourth is x squared times x squared. Now, it could have been x cubed times x to the first. That's x to the fourth also. Okay, but they have to be exactly the same. Okay, so this is the root. If I take the square root of x squared, it's x. So one of these is the root. They have to be exactly the same. So remember, like the square root of 4 is 2. The square root of 9 is 3. So the one that you're multiplying by itself is the root. So x to the 6th is x to the 3rd times x to the 3rd. So the root would be x to the 3rd. And x to the 4th. Okay. Hopefully you notice you have all those numbers. It's always even exponents. So you have a perfect square. That's an S, excuse me. You have a perfect square in a variable if the exponent is even, because you can divide it in half and make 2 of them. So if you tried to do x to the 5th, well, that doesn't make sense because that would be x to the 3rd times x squared, or 4 and 2, or 4 and 1, or it just, you can't make it exactly the same, and we don't do, I mean, I guess you technically could do a fraction, but let's not make it more complicated than it is. Okay? So this is the difference of two perfect squares. X squared, 16. Look over on your list over on the side there, and you'll know that they're perfect squares. Sorry about the bird squawking. Very worried about something. So if you remember this, we had the result of a multiplication problem look like that. We had that because when we multiplied, the middle terms dropped out. So x squared minus 16, the factors are conjugates. Okay? Because that makes it, when you do the multiplication, minus 4, x plus 4, when you do the multiplication, these two, you make one a negative and one a positive of the exact same thing. So when you're factoring the difference of two perfect squares, the factors are always conjugates. Okay, they're exactly the same, and these numbers are the square root. So I generally just do that, whatever the square root is. So same deal here. Take the square root of this, it's 2. Take the square root of this. I know there's a lot involved, but the square root of 9 is 3, and the root is, just take that and divide it by 2. And they're conjugates, 1 plus, 1 minus. That's it. That's the difference of two perfect squares. Just notice if you look at this one here, this is a perfect square, that's a perfect square, not a minus sign. Okay, so this cannot be factored. So just be careful, make sure it has all the pieces. Each piece is a perfect square. Just quickly, I'm going to talk about factoring completely briefly. Okay, when you factor completely, it basically means you're going to have to factor more than once. Always look for your GCF first. Do dots. Remember, dots is factoring using conjugates. Try dots again, and you could possibly do dots a lot. So I'm just going to quickly do these two. You can try them on your own, I guess, if you want. 3 goes into both. There's an x in both terms and x to the first. So I'm going to first do my GCF. And I'm left with x to the 6th minus 9. Those cancel out, y to the 4th. So this is even exponents, so they're perfect squares. 9 is a perfect square number. So leave this, make sure that GCF doesn't disappear, and then we factor using our conjugates. So remember, one's plus and one's minus, and these guys are always, have a pair. So the square root of x to the 6th is x to the 3rd. The square root of 9x to the 4th is 3y squared. And this is the full answer. Okay? There's a minus sign here, and this is a binomial, but this is a 3. So that's not a perfect square because that has to be an even. So I can't factor this anymore. So always look to see if you can factor things again. Here, this is just an example of how you'll be able to factor a few times. GCF is 4. Hopefully that's obvious. So I divide each one of these by 4. I'm left with x to the 8th minus 1. Remember to keep that 1. Anything divided by itself, you need that to do these problems. Okay. This is a perfect square. 1 is a perfect square, so it's x to the 4th plus 1, x to the 4th minus 1. This is a plus here. So, oh shoot, I can't erase that. Sorry. That's a plus. So I can't factor that anymore. But this particular one is a perfect square minus sign, so I can actually do it again. So anytime you're not factoring a piece of a problem, just bring it down. Keep it on the same line with what you're actually going to factor. So this is a perfect square, that's a perfect square. Do the square root thing again. X squared minus plus 1, x squared minus 1. And then again, this is a plus sign, so this can't be factored again, but this is a minus sign. Perfect square minus perfect square. So I can keep going. So remember, bring everything down that you're not using. It's still part of the answer. And then remember the square root there. So this is this factored out completely. All right, have a good day.